This presentation shows how you can deploy TDL models on specific platforms. We use a TDL VisualDistributor tool, which is seamlessly integrated with Matlab Simulink from the MathWorks. This allows a straightforward application of this tool on TDL models developed with the TDL VisualCreator. With the TDL VisualDistributor, we can accomplish both the specification of a particular platform as well as the mapping of TDL modules to a particular platform. In the active rear steering case study, the control system involves two controllers, a dynamics controller that determines the desired value of the rear angle, and a servo motor controller which enforces this value. In the demonstration of the TDL VisualCreator, a platform-independent TDL model of the active rear steering control system has been created. This model consists of two modules, the vehicle dynamics module, which contains the dynamics controller task, and the rear actuator module, which contains the motor controller task. The dynamics controller is executed on a dedicated active rear steering ECU, while the DC servo controller runs on a different ECU, which is near the servo motor. A flex array bus serves as communication means between the two ECUs. To achieve a particular platform mapping for a TDL model, we drag a distribution block from the TDL block set of the Simulink library browser to the TDL model. By opening the distribution block, the TDL VisualDistributor is started. Initially, the target platform consisting of clusters and nodes is undefined. Only the module list contains all the modules of the TDL model. The new platform is defined by adding new clusters with associated nodes. In our case study, with the sake of simplicity, we assume that the flex array cluster with the two ECUs has already been defined. We import that platform. We map the two TDL models to the nodes by dragging the vehicle dynamics module to the active rear steering ECU, and the rear actuator module to the rear ECU. For each module, we must specify the worst-case execution times of the module task on the particular ECU. The dynamics controller task takes at most 1000 microseconds on the active rear steering ECU, and the DC motor controller task needs at most 600 microseconds on the rear ECU. Now we automatically generate both all code and the bus schedule by defining a destination directory for the building process and choosing the Build All menu item. This generates in particular the flex array bus schedule, the numerous parameters of the flex array cluster and nodes, the C source code for each task by means of the real-time workshop embedded coder, the TDL source code, and the glue code for accessing the sensor and actuator ports. Thank you for your attention.